Sir can start now, I think. Hello, sir.
Okay, okay. Oh, yes, yes. Is my voice audible?
We can start, I think.
Yes, I will start now. Okay. If my voice is audible, just please clarify once.
Yes, sir, voice is audible.
Okay, okay. Thank you so much. Let me share my screen. Okay. Please, everyone, unmute yourself. Okay. Let me start the recording. Okay. Today, we are going to start the week 6 assignment. Okay. So the sorry. So the week 6 basically related to your frequency domain analysis. Okay. So mostly we'll focus on the frequency domain things that are like related to. I'm just going one by one. uh, Polar plot. Okay. So second thing I will discuss today, Nyquist plot. Okay. So might be these things are new to you, but actually these are very easier things. I will tell you how to solve the question in very less second in time. Okay. Another thing is the Bode plot. Okay. Okay. So these are the frequency domain analysis. Okay. Frequency domain analysis. Okay. So what will happen here? Here, uh, the things that we are very interested that we have to find the system stability. Okay. So remember that the last lecture we have discussed about that there are lots of types of stabilities there like normal stable system. Okay. Critically stable system. Okay. So in that time we are using time response analysis or you are using RH criterion. Okay. So RH criterion or root locus, these are the things basically you can find the system stability by using time domain method. Okay. But from now onwards, these are the methods like polar plot, Nyquist plot and Bode plot. You will find the system stability and the range of system gain. Okay. What is the range of system gain for the system to be stable or the systems to be unstable or the system to be critically stable by using frequency domain analysis. Okay. So basically here, what do you mean by system gain? Okay. So system gain is that value. Okay. It's just a gain means the amplitude. Okay. So this system gain is what value of the amplitude is systems to be stable or critically stable or marginally stable. So these are defined by various terms. So mainly it is defined by your gain margin. Okay. Okay, this thing. So gain margin is thing. I think you have go through the lectures. You can understand what is the gain margin. So gain margin, the system uh, magnitude at the phase crossover frequency. Okay, it should be one. Okay. So if you do a polar plot, okay, if you do a Bode plot or if you do a Nyquist plot, then from that plot, you need to identify what is this value of omega PC. Omega PC, I am saying the phase crossover frequency. Phase crossover frequency. So phase crossover is the frequency at which the phase of the system equal to 180 degree or minus 180 degree can say. Okay. Okay. Because root locus, the system stability is defined on the left hand side of S plane. The poles are negative. Okay, that's why the phase angle is a multiple of odd multiple of 180 degree. Okay, so basically the phase crossover frequency is the fast crossover frequency when n equal to mostly 1. So we are taking minus 180 degree in a root locus plot or in any plot. If you would do a S domain plot in the frequency domain plot, So this angle is minus 180 degree. So you have to find out the frequency at this point, and at this point what is the magnitude? That magnitude is called the gain margin. Similarly, another term is there, that is the phase margin. These are the very important things to identify the system stability. Okay, phase margin is the uh, gives a idea, because whenever going to deal with the control system design, like you are to design a lead compensator, lag compensator, a PI compensator, PID controller, all these controller. So generally the phase margin you have to keep in between 60 degree to 90 degree, because those people who are doing the actually compensator design, they can understand that if you keep your phase margin in between 0 to 60 degree, then you will not get any value of stable value. So always you have to keep phase margin 60 to 90 degree, so that accurately you can track the system. Okay, so that thing you will in the higher course you will learn about the very complicated about MATLAB. To do MATLAB control system designer, okay, there are lots of tools are available in MATLAB. CISO tool is there. The CISO tool, you can do the Bode plot of any system, and you can identify the gain margin, the phase margin, or using control system designer. Okay, control system designer, another, this is a powerful app in MATLAB. By using this you can find out the system stability, you can tune a PI controller, you can tune a PID controller. Okay, so all these things you can be learned from there. So I'm not going in detail all these things, because these are the things are very robust. Okay, you can learn by yourself, you can watch many YouTube videos are there. Okay, so coming back to my point, what I'm going to discuss today, some numericals related to solving the problems, solving to find out the system gain for system stability, find out the range of system stability. Okay, and basically how to draw the Nyquist plot. Okay, lots of questions related to polar plot, Nyquist plot, and Bode plot. Okay, so let me give my first question to you. Okay, I'll tell you I'll not use any methods that are available in the books. I'll go my own methods. I'll use the shortcut methods. Okay, just 2 3 4 points you can able to draw the polar plot and the Nyquist plot. Let me give the first question to you. Suppose I'm giving a open loop transfer function in front of you, 1 by s plus 1. And remember, from now onwards means whenever solving a root locus question or a frequency domain question, always you have to find out the system stability by using the open loop transfer function. But the system stability you are going to find out for the closed loop system, but not by using the closed loop transfer function, by using the open loop transfer function. So remember, whenever a question is flashing in front of you and is asking about the stability, he is asking about the stability of the closed loop system, but you don't care about, you take the closed loop system, you have to take the open loop transfer function and find out the system stability. So let me please
Sir,
everyone unmute yourself. Okay, any question? Yeah.
sir, my question is that in many examples, it is asked to calculate stability,
Right.
and the transfer function is given in open loop form,
Right.
isn't it? So, in that case, many times by manual calculations, we can understand that poles are at the left hand side.
Right.
But when you are plotting it by any plot,
Right.
it seems to be unstable. How it happens?
It needs to be unstable means I'm not
That
understanding the
means that
last
means
part.
suppose this is your transfer function 1 plus s.
Right.
So we can say that poles are on the left hand side of the display.
Right.
So it is stable system.
Right.
So whenever and suppose there are other systems, let us say 1 upon s plus some equation, 1
Right.
upon s into some equation.
Right.
So they are asking it to find the stability by using Nyquist plot, polar plot,
Right.
or maybe by the body plot.
Right.
So I observed that, but by a manual, just by observing the poles location of the system, we can find out that all poles are lying on the left hand side. System must be unstable. Though you are using any system, though you are using any kind of uh, plot, maybe polar plot, body plot, or Nyquist plot. But system seems to be unstable in that case. How it happens?
No, your point actually, you whatever you are pointing that might not be correct, because what are the things, if you are thinking that suppose by looking at some question, if you can identify, suppose a third order system, fourth order system I'm giving to you, then finding the exact pole location in a calculator, because you don't have a calculator, suppose you're finding the pole location by looking at the question, is very difficult. You cannot predict the closed loop poles or where it is exactly located. So in that case, you cannot predict that by directly looking. Suppose in one case, suppose you are able to find out the system is, by looking you can find the poles at the left hand side, system is stable. But this is for open loop system, you have to find out the system stability always for the closed loop system. Okay, but the closed
Hmm.
loop system is stable or not, you can find out by using time response analysis or frequency response analysis. In time response analysis, you have to go for the characteristic equation, you have to find out the characteristic equation of the closed loop system. Then you have to do the RH criterion and find out the system stability. You have to check on the poles where they're located, and you can comment on that. But if you use a frequency domain analysis, then without doing the closed loop system analysis, by only analyzing the open loop system, we can able to tell the system closed loop stability. That I'll tell you how to do that. Okay, but in practical, what you're pointing out that sometimes it is stable, sometimes it is non-stable. Without doing any analysis, how can we say it? Okay, but you have
That we just by looking at the pole location in open loop system transfer function, we can't comment on the stability.
we can comment it, but you can find out the pole location. But
So
how can you find out the pole
actually,
location?
the sir, please question is incorrect. Please don't try to waste the time.
It's okay, but we can discuss it later if something is in your mind. I don't want to discuss. We can discuss after the class. You can call me. Okay. But coming
Okay.
back to our point, okay. So let me tell you, find out, draw the polar plot, okay, of this system. Draw the polar plot. Let's me quickly tell you how to find out the polar plot. Draw the polar plot of the system. Okay. So how to find out the polar plot of the system? Well, basically what you are going to do, first of all, this is an S domain. G of S, this is an S domain. You have to convert into frequency domain. Please unmute yourself, okay? G of S equal to 1 divided by, you have to put in place of S, you have to put S equal to j omega. Okay. So after this is converted into frequency domain. Then you have to vary your omega. Okay, omega is nothing but the frequency, okay, in radian per second. You have to vary it from 0 to infinity. Once you vary from 0 to infinity, you can put, suppose I am putting omega equal to 0, you can see that where is my pole location. Okay, similarly you put omega equal to 1, you can see where is your pole location. Similarly, where you put omega equal to t and find out the system pole location, or whatever the magnitude, you can see. In the negative also you can vary. Okay, but doing one by one, putting one frequency from 0 to infinity is impossible to draw the polar plot. Okay, for some simple question you can do it, but for complex question, okay, you cannot do it. I'll tell you what are the complex questions, how can I identify which are complex questions. Okay, these are typical questions, but looking like simple, but these are very typical. So let me do how to do this question. Suppose this is the question is flashing in the screen. Suppose you are appearing a GATE exam. In the GATE exam or some competitive exam, I am telling you how to solve this question. So what you do, first to find out how many poles at the origin. How many poles at the origin? Okay. So this is the first step. That is that this thing you have to always use. If you attempt 5 questions, then these are the 5 steps what I'm going to tell you. These 5 steps in your mind, it will be always rotating. So first you have to, first point, immediately one question will come, you have to find out how many poles at the origin. Okay, so here for this question, number of poles at the origin is 0. Okay, so now why I'm telling you, I'll tell you that next. What you do, you put omega equal to 0 now. In this transfer function g of h, I am assuming that the g of h, I am finding out the magnitude of this. Okay, so this magnitude I am denoting as m. Okay, so what, and the angle I have to denote at theta. So these are the things you need to find out. At omega equal to 0, what is the magnitude of the transfer function, what is the phase of the transfer function. So just put omega equal to 0 in this transfer function and tell me very quickly what is the magnitude. If you put omega equal to 0, the magnitude is clearly indicating that the magnitude is 1. Okay, and what is the phase of the system? Omega equal to 0 means you have to see that how many poles at origin is present. How many poles at origin? So 0. If number of poles at origin is 0, your angle should be equal to 0. So it means at omega equal to 0, this angle condition is coming from the number of poles at origin. So these are the methods which I'm telling you, just follow it. So first of all, what at omega equal to 0, you put omega equal to 0 and find out the magnitude. But the angle at omega equal to 0 wholly depends on the number of poles at origin. Suppose in this question, suppose I am adding one s here. One s means now number of poles at origin is now 1. If it will be 1, then that angle at omega equal to 0 only depends on the number of poles at origin. How many poles at origin? 1. So one pole will contribute minus 90 degree angle and 0 will contribute plus 90 degree angle. So how many poles at origin here? 1. So the angle would be now minus 90. Okay. So how I am finding out at omega equal to 0 the angle, that is very important. Okay. So I'm not, but my question is not this one. My question is that I'm giving this simple question. So initially the poles at origin is 0. So that's why the angle here equal to 0. If you understand this point, then the second point you have to find out at omega equal to infinity, what is this magnitude and what is this phase angle. Okay, so magnitude you can see if I put omega equal to infinity in this equation m, if I put here omega equal to infinity, so 1 by infinity is 0. So 1 by infinity is 0. I got the magnitude as 0. But what is the phase now? The phase is now you have to take all the poles and 0 location. Okay. So here how many poles are 0? How many poles are present? 1 by s plus 1. S plus 1 is only one pole. So one pole contributes minus 90 degree. So we write down minus 90. Okay. So once you do that, then what you do, there are two things you need to find out. One thing you have to find out the ending direction. Okay. So I'm just writing it clearly. Ending direction. Okay. Ending direction is nothing but the difference of these two angles. 0 degree minus of minus 90 degree. Okay, so I have to only consider the sign, whether it is positive or negative. 0 minus of minus 90, it is positive. If it is positive, then the angle is clockwise. Okay, CW means clockwise. I will not write again clockwise, just to follow my convention. CW is clockwise. If this value is negative, suppose it will become anytime negative, then the direction will be anti-clockwise. This is the ending direction I am saying. Okay, this is the ending direction. Okay, you understand up to this point what do you mean by ending direction, and what you need to find out. You need to find out at omega equal to 0 what is the magnitude and angle, at omega equal to infinity the magnitude and angle, then subtract these two angles, find out the sign of the angle. If it is positive, then the ending direction I am saying of what ending direction, the polar plot ending direction, whether the polar plot where it will be terminate, whether that direction is clockwise direction or it is anti-clockwise direction. So you can see that if it is positive, then it will be clockwise, and if it is negative, it will be anti-clockwise. And what about the starting direction? Remember, the starting direction will be given by the number of finite pole and finite zero. Okay, so what do you mean by finite pole and finite zero? Finite poles and finite zero means the poles which are finite, not at zero. Let me give an example. Suppose this is a S pen. This one pole is located at minus 1. One pole is located at minus 2. Okay, 0 is located at suppose at minus 3. Okay, so these are called finite poles and finite zero. Suppose one pole will be located at origin, then this is not called at a finite pole. Okay, so finite poles and finite zero are the poles and zero except at origin. Okay, so if you see that starting direction is given by finite pole or finite zero. Okay, if if a finite pole is present and it is very close to the origin, I am just repeating my statement here. If a finite pole is present and it is close to origin, then starting direction equal to clockwise. Okay, if finite 0 is present and close to origin, then starting direction is anti-clockwise. Just these 4 points you have to memorize, because if you 4 points you have to memorize, then all the questions of polar plot and Nyquist plot are very easy. It is like eating a lollipop. Okay, simple thing I am saying. Okay, so you can see that how I am solving the question. I will just use these 4 methods. One is you have to find out the magnitude and phase angle at omega equal to 0. Remember, at omega equal to 0, this angle will be only depends upon the number of poles at origin. Okay, okay. Similarly, at omega equal to infinity, you have to find out the angle and the magnitude. Then just subtract these two angles and find out the sign of the angle. If it is positive, then you can definitely say that the ending direction is clockwise. If it is negative, the ending direction is anti-clockwise. Then one ending direction is over. Then other thing is that the starting direction. The starting direction depends upon the finite number of poles and 0. If a finite pole is present and is very close to origin, then the starting direction is clockwise. Just remember that if pole is present nearer to origin, then clockwise. If 0 is present near to origin, then anti-clockwise. That's it. Let me solve the first question for you. Okay. So what is the first question I have given to you? 1 by s plus 1. Okay. I'm just writing directly. Omega equal to 0. What is the magnitude and what is the angle? 1 at an angle 0. Omega equal to infinity. What is the magnitude and what is the angle? Tell me. At omega equal to infinity, what is the magnitude? 0, right? If you put infinity here, you will get 0. This is your aim. What is the
minus
angle?
90,
What is the angle?
minus 90,
Minus
minus
90.
90,
Minus. Good, very good. What is the ending direction? Tell me, clockwise or anti-clockwise? 0 minus of minus 90. Positive.
clockwise,
Positive means clockwise. What is the starting
clockwise,
direction? You just see in this pole location how many only poles are present. No, 0 are not present. And this pole is located, only one pole is there. No zeros is there. So only pole is present. So starting direction also clockwise. Because if 0 will be there, let's say 0 and 1 pole is there, you can see that which is nearer to origin. Pole is nearer to origin, then clockwise. 0 is nearer to origin, anti-clockwise. Suppose 1 pole 0 combination is there, another like that. 0 is here, pole is here. Then you can see, oh, poles and 0 both are present. So which you have to see, which one is very nearer to origin. 0 is nearer to origin. So starting direction will be anti-clockwise. That like that way. You understand how to find out the starting direction depending on the poles and zeros near to origin. Okay. So once you do that, so in this place on that right hand side, let me draw the polar plot. So how to draw the polar plot here? First of all, you have to find out omega equal to 0. Omega equal to 0, what is the magnitude? 1. 1 is here. Suppose I am assuming that 1 is here. Okay. And what is the direction? 0 degree. This is 0 degree. 0 degree line is this one. 90-degree line is this one. 180-degree line is this one. 360-degree line is this one. If I go on the reverse way, anti-clockwise direction, then it will be minus 90. This will be minus 180. This will be minus 270, you can say. And this will be minus 360. Like that. This is a Cartesian coordinate system. If you go clockwise, how you have to give in the angles. Okay, like that you understand. So now 1 at an angle 0 degree. What is the location? 1 at an angle 0. 0 degree means x-axis 0 degree angle. So here you have to start. Where I am making a round bobbin. So from here you have to start. Now you have to see that whenever you are starting, you have to see that the starting direction is clockwise or anti-clockwise. Okay, the starting direction is clockwise. Clockwise means how I have to move. You have to move in this direction or you have to move in this direction. Clockwise. Clockwise घड़ी का same direction. So you have to move down, right? Clockwise means you have to move down, correct? This is the clockwise direction. Okay, so from 1 you have to go and move in the clockwise direction, but where you have to end, you have to end at minus 90-degree angle. Minus 90-degree angle means this line. This line is the minus 180-degree line, minus 90-degree line. And where you have to reach, you have to reach at a magnitude of 0. Okay, so how can you start, how can you reach? You have to start like that, and you have to go parallel to the minus 90 and reach the 0 at this point. So this is your polar plot for this system. You understand? This is 1 at an angle 0, and this point where I'm ending, it is 0. I'm ending at 0 at a minus 90-degree. Minus 90-degree, it means it is like a asymptote. You have to make asymptote of minus 90-degree parallel to the asymptote and reach the origin, because you have to reach at 0. So simple, this is the polar plot of the 1 by s plus 1. You understand how I'm doing? Okay, if you don't understand, forget about it. I'll give another question. Okay, forget about it. Forget about the last question. Just give me another question. Let me give another question where the magnitude is given by 2u, means this is the open loop transfer function is given to you. How much it is given you? 1 by s plus 1. Let me, I am adding another code, 1 by s plus 2. Then how to draw the polar plot of the system? In 3 lines I will do. At omega equal to 0, the first point in your mind should be coming omega equal to 0. What is the magnitude and what is the angle? What is the magnitude and what is the angle at omega equal to 0? If you put omega equal to 0 means s equal to 0, so 1 by 1 into 1 by 2, so this will be 1 by 2 is the magnitude. And what is the angle? Angle, I told you, at omega equal to 0, the angle will be given by only the number of poles at origin. So here the number of poles at origin is 0, so the angle is 0. Next, at omega equal to infinity, you have to again find out the magnitude and angle. If you put omega equal to infinity, means s equal to infinity, so 1 by infinity is 0. So the magnitude you got 0. But what is the angle you will got? The angle you got, how many poles are there? 2 poles are there. 1 pole contributes minus 90, 2 poles contributes minus 180. So here it will be minus 180. Now you have to find out the ending direction. Ending direction is nothing but 0 degree minus of minus 180 degree. The sign I need, only the sign is positive, clockwise. Starting direction means finite number of poles. Yes, in this question only poles are present. Poles are present means by default it will be clockwise. Okay, so now how to do the polar plot of the system? So you just make a curve like that, Cartesian coordinate system. Locate at 1 by 2. Let's assume that this is 1 by 2 at an angle 0. Okay, you have to start from this point. Where you have to end? You have to end at minus 180 degree. The clockwise direction, make a asymptotic line parallel to minus 180 and end at 0 degree. This is the 0, means magnitude is 0. So this is the polar plot. Okay, like that way you have to move.
Sir, how we have got starting direction clockwise?
Starting direction I told you now.
Yes, yes.
You have to see that whether poles and zeros are there. Here only poles are there. Poles means definitely out of these two poles, poles are nearer to origin, na? Because there are no zeros are present. Poles are present means by default it will be clockwise. If in this question some poles I'm adding here, let me give an s plus 3, then you have to locate which one is nearer to origin. Minus 1, minus 2, minus 3. So poles are nearer to origin. Suppose this value I'm giving here s plus 0.5. Then you can see that which one is nearer to origin, 0 or poles?
Pole.
No, 0.5 will come first, right?
0. Yes, yes, sir. Yes, yes.
So now in that case you can see that 0
It
is
is
nearer
anti.
to origin, so it is anti-clockwise. So
Okay.
in both, now in some questions where both poles and zeros will be present, so in that case it will be you have to identify which one is nearer to origin. But
Okay.
by default in some question the only poles are present, so by default it is clockwise. Poles means clockwise, 0 means anti-clockwise, but you have to find out if combination is present, then you have to find out which one is nearer to origin. That's it. Got my point?
Yes, sir.
Yes, sir.
Okay, so this is the polar plot. Okay, but actually suppose you are see from this question how many questions can be possible. This is a very simple question looking to you. Okay, but for this question, if I'll ask you, find out the k value, okay, for the system to be stable, or find out the k value uh, uh, for the system to be having a sustained oscillation, find out the omega. So all these things you can be find out from this question. I'll tell you, let me quickly solve another question, and from after that we'll do this, all this, okay, all this thing. Now, okay, otherwise you can, I will solve this here, let me see. So suppose this question you have solved it in 1-2 seconds, but the point is that it is not the way you are solving, it is not the way, but the way is that how to answer further questions. The further question is that, let me ask you, find out this point, because this polar plot is crossing my minus 90-degree line at this point. Okay, let me change the color. Let it is crossing this minus 90-degree line at this point. So he will ask you to find out, when the polar cloud is crossing this point, what is the frequency? Okay, what is omega value at this point? Okay, so can anyone tell me how to find out what is the omega value at this point? I have already given this hint in the root loop course. Okay, so I told you.
We have
Okay,
to rationalize the function and we have to equate the imaginary part equal to 0.
imaginary part equal to 0. You can do that. You can do, but I will not go to in that way. I'll just do my methods how I'm solving it. Okay, so you can see that this point is asking, this point lies in the imaginary axis. Okay, so this point lies on the imaginary axis. I told you in the last class, suppose one s term is there, another s square term is there, another s cube terms is there. So out of these points, which are means the real parts, which are imaginary parts. S means it is j omega, this imaginary. S square means it is j omega into j omega, means minus omega square. It is the real part. SQ means again it is the imaginary part. So what is the understanding from this? If you go for S4, it will be a real part. So what is the understanding? The understanding is that if odd values of S are present, then that gives me imaginary terms. If even values of S are present, that gives me real terms. Okay, that is the understanding from this. So if I apply this concept in this question, then I'm not erasing it, it will be better for you. I will later follow this will be imaginary. Okay, I'm doing here. Okay, if you understand this part, that imaginary terms will be given by even number, odd number of, or this odd odd power of s, you can write down odd power of s gives imaginary terms, and even power of s gives you real terms. Okay, is the screen is visible? Yeah. Is my
So
screen
screen is visible, no problem.
okay? Okay, just 1 second.
Slide is not visible.
Okay, just 1 second, sir. Actually, whatever I have written, it gone. I don't know how. I will try to take again and share the slide. But for now, where I have discussion is that, let me quickly draw that question. gh equal to 1 divided by s plus 1 and s plus 2. I am solving this question. At omega equal to 0, this amplitude is 1 by 2 at an angle 0. Omega equal to infinity, this will be 0 at an angle of minus 180. So ending direction will be positive, so clockwise. Starting direction is poles are present, that's what is clockwise. If you draw the polar plot of the system, this will be start from 1 by 2 at an angle 0 and it will be moved like that here. So I am asking you to find out what is the value of omega at this point. You understand that the odd part will be imaginary terms and the even part will be
Yes,
your
yes.
real part. After this we have covered. Okay, so now what you do, you just multiply quickly, multiply this term s plus 1 and s plus 2 very quickly. You just solve it. S plus 1 and s plus 2, it give you s plus 1 is s square plus 2s and s is 3s and 2. This equal to 0. Okay, once you do this equal to 0, what you do, you have to tell me, I am asking you to find out this point. This point means that point is a imaginary point. Okay, that is a imaginary point. Imaginary point should be present and there is no real part. It means imaginary point should be there and there is no real part. It means the real part you have to make it 0. So a square plus 2 you have to make it 0 and a square equal to minus 2. A square is nothing but your j omega square. It means minus omega square equal to minus 2. So omega square equal to 2. It means omega equal to root 2. So this is the value of omega at this point, root 2. You understand how I solve this question?
So can you repeat s square plus 2 is equal to 0? How you got it?
I told you, na sir, it is the, you understand that I am asking you to find out the omega value at the imaginary point, right? At this
Yes,
point.
sir, yes.
Imaginary point means imaginary value has to be exist. A real
Yes,
part has to be make it 0.
yes,
So what are the real part in this? Even part are real part, right?
yes.
So what I
So
did
s
in this
square plus
equation,
2 is equal to 0. Correct, correct,
I
correct.
make it like that.
Yes, yes.
This is one method which is the most powerful method. If it is a fourth order equation, fifth order equation, if you find out omega, then you can easily find out. Otherwise, what you do, you find out omega, you find out magnitude. Again, at this, I'm adding another question. At this point, if you find the omega, can you please find out at this point what is the magnitude m? Yes, because you already find out omega
Root 2,
equals
root
root
2.
2.
Root
So
2
what?
only.
No, this is the omega. This is the
Uh,
frequency at this point. But what is the magnitude at this point? So magnitude means this is the magnitude. M equal to how much? 1 by root over of omega square plus 1 into omega square plus 4, right?
correct.
Put the value of omega square equal to how much? 2. Put omega
Root
square
2.
equal to 2. Okay, got my point? You just put the value of omega there and find out the
2
magnitude.
plus
You
1,
understand?
3, 3, 3, uh, root 6.
Yeah,
Root 6 into root 3. 1 upon root 18.
let me do for you. 1 by omega
Root
square is how much? Omega square is 2. 2 plus 1 is
2
3.
plus 1, 3.
3
And
into
2 plus 4, 6. Root 18.
4. Root 4. Root 4 omega square equal to 2 root 6 root 18.
1
So
by
1
3.
by root 18. Okay, 1 by root
Yes,
18. So this is
yes,
the answer. Okay, if you
yes,
understand this
yes.
part, let me go with this is the most standard question. In any examination you go, you'll find this type of question. Okay,
Now, sir, suppose in the same problem, if they ask 1 upon s plus 1, 1 upon s plus 2. Suppose they ask find out the stability by using polar plot. So we can say that it is stable system only.
no. How can you say that? You can I have not covered anything related to stability till now. You just wait and I will come back. Okay.
Okay, okay.
Okay. Just I am showing you how to plot the polar plots. Okay, I will come back to the stability. Now, this is the standard question. Question number 3 is a standard question. This is a very standard question. How the question will be? It will be like that. 1 by 1 plus in something is they will give like k1s 1 plus k2s. Okay, you can find out all. Or suppose in terms of time it will give. Okay, so 1 divided by 1 plus st, 1 plus st1, 1 plus st3. This is similar type of question. So for the same question, now you have to find out the polar plot. Simple. At omega equal to 0, what is the magnitude? 1 by 6 at an angle 0. Omega equal to infinity, it will be 0 and 3 poles are there, so it will be minus 270. So what is the ending direction? Ending direction is 0 minus of minus 270 is positive, so clockwise. Starting direction is how much poles are present, so poles, so clockwise. Now you can quickly draw the polar plot. So it will be start at some point 1 by 6 at an angle 0, and it will move at clockwise direction and it will be reaches to minus 270. So like that you can go and you can come to 0. Okay, so like that you go and reach the 0 point. This is minus 270. Okay, if you move in the clockwise direction. So this is the polar plot. Okay, so now in this question, the most important question where they will ask you to find out the gain margin of the system. So by looking at the question, how to find out the gain margin? So what do you do? For gain margin, you know that you have to find out the phase crossover frequency. For gain margin, you have to find out the phase crossover frequency. The phase crossover frequency is the frequency at which the phase angle is minus 180 degree. It means you have to find out the omega value at this point, because this is the minus 180 degree line. So first find out the omega PC. This point is by default called omega PC. So how to find out this line I told you. So this is the real part. Okay, real part has to be exist. Imaginary part has to be 0. Make the odd terms equal to 0 in this equation. Make the odd terms equal to 0. So if you simplify it, it will be gives you SSS is SQ, 2s, 3s and s is 6s square plus 3, 6, 2 and 3. It will be 11. It will be 11s plus 3 into 2 just 6. So this is the, if you multiply this 3 terms, you will get this term. So in this term, if you find out the real part, making the imaginary part equal to 0. So what do you do? Imaginary parts are like SQ plus 11s equal to 0. It means s square plus 11 equal to 0. It means your omega equal to root 11. So your omega PC, the phase crossover frequency directly got root 11 radian per second. Once you know omega PC, then you have to find out the magnitude at this point. Okay, for gain margin is nothing but 1 by magnitude, right? So find out the magnitude and make the inverse, that will get the gain margin. But if you find out in terms of logarithm, then it will be 20 log 1 by m. Okay, this is the gain margin. You understand how to find out the root locus and something related to find out the omega and something related to find out the k value. You understand?
From WPC is equal to root of 11, you have to put the value in the transfer function to get the value of m.
Right.
Yes,
And gain margin nothing but 1 by n.
1 by m.
Means
In
if you,
dB, we can take 2 log of 1 by m, correct?
not 2, this is 20 log 1 by
20 log of, yes.
n. Okay. See, these are the questions. These questions are very, very famous question, but you can solve it within 2 seconds. Means maximum, not 2 seconds. It's 20 to 30 or maximum 1 minute. Don't waste your time solving these simple questions, taking 5 minutes, 2-3 minutes. It will kill your time. Okay. If in competitive examination, always try to focus the concept how to solve this question in a quicker way. That is the okay. So if you understand this question, let me go slowly increase my difficulty level. Okay, let me find out, let me give you another type of question where the poles I'm adding now, because initially the zeros I'm adding, s plus 3. Now I'm giving some poles at origin, s square, s plus 1. Now do the polar plot of this. Very quickly you do. I'm just writing out at omega equal to 0. Let me change the color. At omega equal to 0, What is the magnitude and what is the angle? Magnitude is, if you put omega equal to 0 in the system, the magnitude will be by default, it will be infinity, because this is the pole at 0 is there, so 1 by 0 is infinity. And what is the angle? The angle will be gained by the number of poles at origin. How many poles at origin? 2 poles at origin, so angle will be -1. At omega equal to infinity, what is the magnitude, what is the angle? The magnitude you have to find at omega equal to infinity, 1 by infinity is 0. Okay, but what is the angle? Angle is, now you have to see how many poles and zeros are there now. So you can see how many poles are there. 3 poles are there. 1 2 3. How many zeros are there? 2 zeros. So 2 zero contribute plus 180. 3 zeros contribute minus 270. So what is the, which one is resultant? Resultant is -90. Okay. So this value is -90, and it can be sum of poles plus sum of zeros, right? This angle is nothing but sum of poles and zeros. Resultant you have to take. Okay. So previously all the poles are there, so that's why you have only counting the poles, but now zeros is coming into picture, so you have to calculate the equivalent number of poles and zeros. So 2 zeros contribute 180, 3 poles contribute -270. What is the equivalent of -270 plus 180? Just add these two, so it gives you -90. So now you have to find out the ending direction. Now you see, what is the ending direction? Ending direction is -180 minus -90. It will be negative, so it will be anti-clockwise. Starting direction, you have to see whether the poles is nearer to origin or 0 is near to origin. Poles is near to origin, so it will be poles, it will be clockwise. So remember now here, ending direction and starting directions are now opposite. Okay, if you start with a clockwise, you have to end in anti-clockwise. Okay, so how to do that? How to do the polar plot? Let me quickly draw here the polar plot. So at which point you have to start? You have to start 0. This is -180. So you have to start at -180 degree line. Okay. From where you have to start? You have to start from infinity. So you have to start from infinity. You have to start from infinity in this direction. One person can start -180 infinity from bottom side also. But you have to see the starting direction. What is the starting direction? Clockwise. Clockwise means, and you have to end in anti-clockwise, but where you have to end? At -90 degree at 0, means at 0 you have to reach at 0, but I am making an angle of -90 degree, so it will be, you start in the clockwise, you cannot start in the anti-clockwise, you have to start in the clockwise direction, you have to move like that, then you have to move in the anti-clockwise direction, then you have to reach like that. Okay, like that, it will cross the axis. Okay, this is the starting direction, you can see it will be a clockwise. The ending direction, you can see it will be anti-clockwise. You understand this question? I think this is a little bit typical question, because starting direction and ending direction, when they are different, definitely remember it will cross some axis. Okay, so in this question, suppose the starting direction and ending direction both are clockwise, then how the polar plot will be? The polar plot will be somewhere here like that. If you start from -180, it will follow clockwise. It will be reaches at it will not reaches at -90. This question is not possible. Okay, forget about it. My hypothesis is wrong. So it will cross the axis. Okay, you just see the starting direction and the ending direction is clockwise and anti-clockwise. Okay. You understand? Are you there? Everyone is there? Anyone please respond whether you understand this part or not.
Yes, sir.
Yes.
So if you understand, then tell me what is the value of omega? What is this value of omega? Please everyone calculate. Otherwise my explaining all these things will be vain. Okay. Please find out what is the value of omega and use the shortcut. Don't go in the long cut. Tell me what is the value of omega. Omega is which point? Omega is a point which is on the real axis. So what you do, keep the real parts, make the imaginary part equal to 0. Imaginary part is the odd part, make the odd part equal to 0. But the doubt is in the mind is that there are some parts are there in the pole, some part is there in the 0. But how to find out the characteristic equation? So what you do, for which equation you have to make the odd parts equal to 0. That is the important thing. The characteristic equation is nothing but like that. So what you do, all the terms you multiply. Simple concept. All the terms you multiply. A square into s plus 1 into s plus 2 into s plus 3. All the terms you multiply equal to 0 and find out, make it, and from there, after multiplication, make the odd terms 0. From that, you will get the omega value. Okay. This part I am just adding for your references. Okay. Is it okay for you? Okay. Let me move to the next part. Okay. So remember, if you are very comfortable in polar plot, then drawing the Nyquist plot, it's like nothing. Okay, let me do one question for you. 1 divided by s into s plus 1 is g of s. Just asking you find out the Nyquist plot. I'm just showing you how to draw the plots, polar plot and Nyquist plot. So how to draw the uh, Nyquist plot. So remember three things I will just tell you in this slide. Okay, this slide will be just three things. The first thing is that if a question will come to find out the Nyquist plot, remember the first point that should be come in your mind, that find out the polar plot, because you are very confident that how to draw the polar plot. Second thing is that just mirror image. Okay, mirror image, take the mirror image of the polar plot. But first step is that find out the polar plot. Second step, you have to find out the mirror image of the polar plot. And the third point, which is very critical, you have to identify now. So remember that find out the number of poles at origin. Find out the number of poles at origin. Remember, I'm writing one line. Okay, number of poles, just me write in heading. This is the extension of point 3, this is point 1, this is point 2, point 3. This is the extension of point 3. So after finding the number of poles at origin, you have to see that number of infinite radius half circles equal to number of poles at origin. Means suppose in this question one pole is at origin. Poles at origin is 1. Okay, it means in the Nyquist plot there is there is only one infinite radius half circles. So number of infinite radius half circles equal to 1. Number of infinite half circles equal to 1, and that direction is always clockwise. Remember, the Nyquist law direction is always clockwise. Okay, so how to solve this question? So there are three things you have to keep in mind. First, find out the polar plot. Second, find out the mirror image of the polar plot. Third point, you have to find out the number of poles at origin. If two poles at origin means there are two infinite radius half circles, and the direction of the infinite radius half circle is always clockwise. Let me solve the question for you. Okay, so 1 by, the question was 1 by s into s plus 1. This is the question to you. So first you find out the polar plot. So for polar plot, what you do, you have to find at omega equal to 0, at omega equal to infinity. At omega equal to 0, what is the magnitude and angle? What is the magnitude and angle? Magnitude is infinity. Because if you put omega equal to 0 means s equal to 0, so 1 by 0 is infinity. Okay. So you got amplitude equal to infinity, but what is the angle? Angle, I told you, at omega equal to 0 depends upon the number of poles at origin. So how many poles at origin there? Only one pole, so minus 90 degree. Similarly, at omega equal to infinity, you have to find out the magnitude and angle. What is the magnitude at omega equal to infinity? At infinity, 1 by infinity is 0. So how many poles and zeros are there? Only two poles are there. So one pole is contributing minus 90, two poles are minus 180. So once you do this, find out the ending direction and starting direction. So what is the ending direction? Ending direction is minus 90 minus minus 180. So it will be positive. So it will be clockwise. And only poles are there, so poles, this will be clockwise. So both are now clockwise. So let me do the first polar plot. So where the polar plot will be start, it will be start at omega equal to 0, and it is starting from infinity. You can see it will start from infinity, but at which angle? Minus 90. This is minus 90 degree, but you have to starting direction is clockwise. Clockwise means this is the clockwise direction, right? So this is the clockwise direction, so you have to move in this direction, but you have to start from here. Let me start by making an asymptote which is parallel to minus 90 degree in the clockwise direction. I started, but where I have to end? You have to end at making an angle which is parallel to minus 180, but you have to end at 0. So how to do? Let me do perfectly. So you start like that, you go and go like this and reach at this point like this. So this is the polar plot for it. Both are, now you can see, starting direction and ending direction are clockwise. If the polar plot is okay for you, then what you do, you find out the mirror image of this polar plot. Okay, this the mirror image will be something like that. Okay, but in what, just remember that the direction you have to keep continuous. Okay, so if you reach at this point, then you have to start from this point. The direction you have to keep continuous. Okay, same direction you just follow, where you have terminated, from the same point you started. Okay, so this is the first point is over, the polar plot, and the second point is that the mirror image of the polar plot is over. Now you have to check the third point. How many number of poles at origin? Only one pole at origin. So how many number of infinite radius half circle? Only one infinite radius half circle. Infinite radius half circle means radius is infinity. This is infinite radius half circle. It will cover the entire infinite radius. Okay, but the direction of that infinite radius is clockwise. Okay, clockwise means from where your mirror image will end. The mirror image is ending at this point. This is the ending of the mirror image, and this is the starting of the original, okay, polar plot. This is the starting of the original polar plot. This is the ending of the mirror image. So where you end, from that point you have to draw an infinite radius half circle, and you have to end where you have already started already. So this is the direction. So now this is the clockwise direction. So this is your Nyquist plot for the question. Everyone understand how I draw the Nyquist plot?
Yes, sir.
See, Nyquist plot drawing is not a big deal. Okay, if you just follow these 3 points, then Nyquist plot is just like nothing is there. Okay, you understand this point? How I draw this Nyquist plot of the question?
So radius of semicircle is
Infinite. This is an infinite radius half circle. It covers the entire right hand side half plane. This
okay.
radius is infinite. But suppose
So how
some
can you call it as infinite? Because we are having some radius value.
no.
Infinite radius.
See, I am denoting this radius is infinity. I am saying this r is equal to infinity.
Okay, okay, yes.
Because I cannot draw infinity, I don't know where I will exit. But I have to show you in the paper
Yes, yes.
how to draw that.
So starting direction we have to always take depending upon the number of poles. है ना?
Yes,
If
starting
pole is
direction
present, that we have to take
angle.
clockwise.
Yeah, yes. Starting direction angle, you have to see that how many poles at origin. Okay, see these 3 points is not that easy. If you don't solve much question, 5, 6 question, then you cannot able to solve this method. You cannot adopt this method. By adopting this method in your mind, by adopting this method to your students, you have to at least do 5, 6 question based on that. Then you have to get a handy that okay, this method works. Okay, let me quickly give you another 2 questions to you. Okay, so see, uh, let me give another 2 questions, otherwise it will not be clear to it. Let me give this question. You can do it by just on pen and paper. Okay, this is a very simple question. Let me give you. Then how to do? I am just asking you to draw the Nyquist plot. So what do you do? First, you draw the polar plot. How to draw the polar plot? You just do this: omega equal to 0, omega equal to infinity. What is the magnitude and what is the angle? You find out. This is a simple calculation. So at omega equal to 0, 10 divided by 0 plus 1 is 10. Amplitude is 0. What is the angle? Angle will be given by the number of poles at origin. So here no poles at origin. So angle will be 0 degree. So now at omega equal to infinity, if I put infinity in place of s, so 10 by infinity is equal to 0. So amplitude we got 0. But what is the angle? Angle is contributed by the number of poles and zeros at origin. So not origin, it's total number of poles and zeros. So here in this question only one pole is present, so minus 90 degree. Then immediately find out the ending direction. Okay. So first to find out ending direction, because it will be easy to subtract 0 minus of minus 90, it is positive, so clockwise. Starting direction, only poles are present, so it is also clockwise. Once you do that, then what do you do? Here you draw the polar plot. You have to start with 10. This is the value positive 10 at an angle 0, but you have to move clockwise. Okay, and you reach at 0, but by making minus 90 parallel to minus 90. So how to do? You have to start with this. Okay, let me draw another color. So you have to start at 10 at an angle 0. You have to reach by this. Okay, so you read this is minus 90 degree. You are moving in the clockwise direction. Fine. You are reaching at 0, satisfying by making an asymptotic angle of minus 90 degree. So this asymptotic angle is minus 90 degree. So once you do, then you have to draw the mirror image of this. Mirror image is of this what? I told you that at where you have end, you are starting. I'm just writing it. This is the starting point. This is the ending point. This point is the ending point. Then the mirror image will be start from the ending point. Okay, mirror image is just a mirror image. It will be like that. Okay, but after doing this, if suppose somebody will find out how many number of infinite radius half circle, there are no infinite radius half circles. So simple. This is the Nyquist plot. So this is the Nyquist plot. For this question, this is the Nyquist plot. Got my point? Okay, let me go quickly solve some
Yes, sir.
questions for your and for just practicing this my methods. Hopefully it will work in all the questions. So for this question, let's find out quickly. At omega equal to 0, omega equal to infinity, find out the magnitude and theta. Magnitude and theta. So what is the value? This will be 10 divided by 2 is 5. Number of poles at origin? No. So 0 dB. Omega equal to infinity. Infinity 1 by infinity is 0. So number of poles and zeros. So two poles are there. So minus 180. So ending direction is positive. So clockwise. Starting direction is poles. So it will be also clockwise. Now I am doing the polar plot. First step is draw the polar plot. Let's change the color. You have to start from 5 at an angle 0. Okay, you have to move clockwise, but you have to make an asymptotic angle parallel to minus 180. So you start it like that, make an angle minus 180 degree parallel and reaches 0. Okay, this is the 0 point. So this is your polar plot, original polar plot. Once you do the original polar plot, then what you do, you take a mirror image of that. The mirror image will be something like that. Okay, so the mirror image will be something like that. Okay, this is the polar plot. This is polar. This is mirror image. So how many number of infinite radius half circle is there? No.
No,
So
no.
okay. Now the point is that why I'm doing all this thing. I'm doing all this thing. You have to find out the system stability. In Nyquist plot, if you know the polar plot, if you know the Nyquist plot, then if you go through any books, if you go through such lectures, then you can understand that to finding out the stability means number of poles on the right hand side equal to the number of encirclement about -1 plus j0 point. So in the Nyquist plot, number of right hand side poles, okay, right hand side poles equal to number of encirclement, number of clockwise encirclement, okay, in about which point? About -1 plus j0 point, -1 plus j0 point. If you understand this statement, then you can easily find out whether the system is stable or not, or how many poles are there in the right hand side and the left hand side. Let me quickly come to one question. Okay, let me solve one question for that.
Sir, it is number of right hand poles, na?
Yeah, number of right hand poles. Okay, number of right hand side poles equal to number of clockwise encirclement about -1 plus j0 point. I'll show you how to do that. Let me go to a question. The question is like that: 10 divided by s square plus s plus 1 plus s plus 2. Do the Nyquist plot and find out the system stability. System stability means how many number of poles on the right hand side. Whether if there are 0 poles on the right hand side, then you can easily say that the system is stable. So let me do the polar plot first. Because any question on the Nyquist plot, do the polar plot, because you know very well how to do the polar plot. Omega equal to 0, omega equal to infinity, magnitude and angle. What is the magnitude? Infinity, because 1 by 0 is infinity. And how many poles are there at origin? 2 poles, so -180 angle is coming. At omega equal to infinity, what is the magnitude and angle? At omega equal to infinity, so 1 by infinity is 0. So magnitude is 0. Angle is how many? Total 4 number of poles are there. So 1 pole is -90. So 4 poles are -360 degree. Okay. Once you do that, find out the ending direction. Ending direction minus 180 plus 360 to positive. So clockwise. Starting direction, poles are there only. So clockwise. So do that polar plot first. Change some color. What is the polar plot? Where you have to start? You have to start from infinity directly. So let me, this is minus infinity. But at which angle? You have to make an angle -180. If you start, your starting direction should be clockwise. So clockwise you have to start Okay, then you have to move in the clockwise direction and you have to reach 0 at minus 360. This is minus 360, right? So starting with 0, this will be minus 90, minus 180, minus 270 and minus 360. So you have to do and go like that. Clockwise, everything is clockwise. So this is a polar plot. Once you do the polar plot, you have to take the mirror image of that. Let me do the mirror image. Okay, so this is the mirror image. It's the same direction you follow. Which direction your initially it is terminated, same direction you follow it. Okay, both are infinity. Okay, so now you see how many number of infinite radius half circles. There are two poles at origin. Two poles at origin. So two infinite radius half circles. Okay, so first draw one infinite radius half circle. I told you where you have to start the infinite radius half circle, where a mirror image terminates. This is the actual polar plot. I'm just writing which actual polar plot. This one is the mirror image. Where the mirror image terminates at this point. This is the termination point of the mirror. Okay, this is a, I'm just putting a yellow color. Here you have to start your infinite radius half circle, but in which direction you have to move? You have to move in the clockwise direction. I told you that the infinite radius half circle always clockwise. Okay, so move an infinite radius half circle, move one infinite radius. Okay, I already moved one infinite radius, then but another is there, so two. So start, you just continue that, continue, and where you have to end it, where the actual polar plot started here. Okay, now this is the whole Nyquist plot for you. Direction is like that. Okay, you understand how this polar plot will be?
Yes,
Now the question is that for this question find out the number of right hand side poles. But
infinite radius will be present only for when the poles at origin are there.
yes, yeah. Now in this question find out the system k value for stability. Then the k is not given, but in most of the question the k will be given here. Okay, I just for simplicity I have not written, but in most of the question where they will ask you to find out the k value for system stability, the k should be there. Now for the system, you have to find out the system stability for k. First of all, you find out the number of encirclement about -1 plus j0 point. You can see that clearly these are infinite radius half circle. Okay, infinite radius half circle. I may assume that the -1 plus j0 point is here. Okay, because definitely the -1 plus j0 point should be somewhere. If it is not here, it can be here, it can be here, but it can be here, but it is inside this infinite radius half circle. Okay, because the radius is infinity and your -1 will be somewhere here. Okay, let us now suppose your -1 plus j0 point is here, but you don't know where exactly. Okay, so tell me, if the -1 plus j0 point is somewhere here, then how many number of total number of encirclement about this -1 plus j0? See, here you started now one encirclement, then discontinue again. There is one encirclement. They again continue here and another encirclement. Two encirclements. So number of encirclement is 2. You can see if you start from this one point, then you move like that, complete it like that, then again you move here another times, then you come back to the same point one. So how many encirclement, total encirclement is 2. So n equal to 2. If n equal to 2 means definitely the system is not stable because there are two number of poles on the right hand side, and that are the closed loop poles on the right hand side. Okay, Because see, by looking at this question, can anybody tell me how many open loop poles on the right hand side? How many number of open loop poles on the right hand side?
0 हो सकता है क्या?
0, because there is no poles on the right hand side by looking at this question. But we cannot conclude the system stability from open loop transfer function, because system stability is always defined for closed loop system. So if you can easily quickly draw the Nyquist plot, then you can easily say that if you find out the closed loop system stability by taking a unity feedback system, then definitely you will get 2 poles on the right hand side. So that's why the system is unstable. So please unmute yourself. Okay, making sound.
Sir, in this example, how the two infinite radius half cycles drawn?
Okay, that part you not understood. Okay, let me erase that part.
No, sir.
Good, because I thought someone has not to understand, because I just need to explain. You understand this, na?
Yes, yes.
Yes, sir.
Yeah. Then I told you there are two infinite radius half circle. The infinite remember this. The infinite radius half circle will start at where the mirror image will end. Go back to the previous question. You can see the infinite radius half circle where it starts, where the mirror image end, right? This is the mirror image. This is the actual polar plot. So where the mirror image will end, because you have to continue, because you have to make a close encirclement. So making a close encirclement is possible only where the mirror image will end. If from that point you have to start the infinite radius half circle, and you have to end at where you originally started. Originally starting the point, let me call this point is 1, this point is 2, then your infinite radius half circle will start from 2 and it will end from 1 where you have already started. So like that you have to do here. Where you have the original plot is started at this point 1, right?
Yes.
So make an infinite radius half circle, and where you have to infinite radius half circle start where the mirror image is end. The mirror image will end at this point too, right? Right? This 2 point your mirror image ends, right?
Yes.
Yes,
So
sir.
from this point you have to make a clockwise encirclement. You cannot go anti-clockwise encirclement. You have to make always clockwise encirclement. So you have to make clockwise encirclement 1 over, then 2, continue that and reach the original point where you have started. That's it.
Encirclement will be always clockwise.
Yeah, your infinite radius half circle is always clockwise.
Okay.
Sir, one small doubt, sir.
Yeah, sure.
Sir, ending direction and the starting direction of polar plot, will you just explain, sir? I didn't. Polar plot, clockwise,
Yes,
sir.
yes. See, for this question I am telling you, ending direction is nothing but whatever the phase angle is here, minus 180. So what you do, minus 180 and subtract minus 360. See the sign of this. What is the sign of this? Positive or negative?
Positive.
Positive.
If it is positive, it is clockwise. If it is negative, it is anti-clockwise. That's it. Starting direction, always see if poles are there or zeros are there. If in this question only poles are there, so clockwise. If suppose in this question, if I'll another question, let me suppose in this question is given like that: s plus 1, s plus 2 divided by 1. So what is the ending direction, starting direction for this question? Zeros are there, only zeros are there. Should be anti-clockwise, right?
Yes.
But suppose mixed combination is there: s plus 1, s plus 2, s plus 3, s plus 4. This is the transfer function. Now tell me what is the starting direction. You have to first see which one is nearer to origin, poles or zeros.
Zeros.
Yeah, 0 is there nearer to origin because it is starting from minus 1. That's why it's over. So anti-clockwise. Got my point?
Yes, sir.
Sir, about encirclement,
Hmm.
it will be always in the clockwise direction. That is independent of.
Yeah. See, sometimes if you cannot, it depends on the polar plot direction. Okay. Sometimes
Okay.
the polar plot direction will tell you that See, infinite radius half circle is always clockwise, but polar plot direction can be clockwise, anti-clockwise. Now you cannot say like that.
Yes, 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 yes,
Okay,
yes.
so it is just a combination. You cannot say, but
Yes, sir.
okay. Let me give one more question. This question, I think it is. I'll just give this a tougher question to you. It's very tough question. Write down this question, everyone. GH divided equal to K divided by S plus 1, S plus 2, S plus 3. And he's asking us to find out K for system stability. From Nyquist plot. Okay. You can solve this question by many methods. You can use Bayes criterion, you can use root locus, you can use anything. But as I'm dealing with polar and Nyquist plot, you will just do by Nyquist plot. Okay. Otherwise, it will be very, very handy for you. Okay. So how to do? First, to find out the polar plot. Doing the Nyquist plot, the first step is that draw the polar plot. So first that you have to find out omega equal to 0, omega equal to infinity. At omega equal to 0, what is the magnitude and what is the angle? Can you please unmute yourself, sir? Yeah,
Magnitude will be 6.
magnitude will be k by 6. Okay, it will be k by
K by
6.
6 is K by 6.
And what is the angle? 0.
Yes.
What is the magnitude is here?
It
1
will
by
be
0. 1 by
0.
infinity is 0. Simple.
Yes.
And this will be minus 270. Correct?
273 poles. Yes.
Yes. Ending direction is nothing but 0 minus of minus 270. It will
It
be
will be clockwise.
clockwise, positive. Starting direction is poles are there. It will be
It will be
clockwise.
again clockwise.
Now you do the polar plot of this. Start from k by 6.
K by 6.
Move in the clockwise direction and reach at 0 by making minus 270 value.
Yes.
Do this one. This direction is for your understanding.
Yes, sir.
Mostly I will not do it. Otherwise,
Yes.
make again what you do, make a mirror image of that. Mirror image
Yes.
is something, it will cross something like that and reach at this point.
Yes.
Okay. This is the point. Okay. So for now, the point is that he's asking us to find out the system stability. So to make the system stability, you have to find.
Encirclement will not be required because there is no polar to origin. Na?
No, here no encirclement is there because you
Yes.
can see that the Nyquist plot is now complete, right? This is a
Yes. Yes.
complete plot. Wherever it starts, it ends that point.
Yes, sir. Yes. Yes. Yes.
Now, for the next step is that you have to find out this location. What is this value? Tell me what is the omega value at this point and what is the magnitude at this point. What is the omega and what is the m at this point? I will not tell you. I already told you how to solve this. Tell me what is the omega value.
You should unmute, otherwise it is disturbing.
Please, everyone, please unmute.
If you just want to say yes, if you cannot unmute, it is disturbing very much.
Yeah. Okay, sir. Just tell me what is the omega value at this point. Omega means this is a real axis. In the real axis, the imaginary terms are 0. Imaginary terms are the odd part. Okay, make the odd part equal to 0. So in this equation, solve the equation and find out the omega. Do it quickly. I'm just waiting for your answer.
Sir, 3
It cannot be 3. Please check it once more. Solve the equation. Now just simply solve SQ plus 3, 2, 6. How much?
Root 11.
Root 11 is fine. Correct. Root 11 is the answer. Omega equal to root 11. Once you find out the omega equal to root 11, then your next step is that put this root 11 in this transfer function to find out the magnitude. So what is the magnitude of this transfer function? M, I'm denoting as mod. So omega square plus 1 square. Next, this will be 4 plus omega square. And next, this will be 9 plus omega square. Omega square is nothing but 11. Put the value of 11 and tell me what is the value. K divided by, this will be 11 plus 1, 12, root 12. This will be 11 plus 15, root 15. And this will be 920. How much this value will be? Be K divided by 60. 20 into 15, so 15 into 20 is 30. 12 into 3, 3600. 3600 square root is 60. So K by 60. So this point, you got that. What is the value at magnitude at this point? This is K by 60. Okay. So now you have started at some point K by 6. Now wherever you are crossing this point on the imaginary axis, this is K by 60. Now he is asking us to find out the system stability. To find out the system stability, you have to see that where is the -1 plus J0 point. Okay. So remember that number of encirclement about -1 plus J0 point equal to number of right hand side poles. It means if you want your system to be stable, then how many poles on the right hand side? 0, right? Yes or no? If your closed loop system you want stable, because in the question he is asking us to find out the K value for system stability. It means if you want to make your system stable, then how many number of encirclement you want? Actually you want 0, right? You don't want any encirclement.
For the system to be stable, we want 0 encirclement.
Right? You understand this line?
Yes, sir.
Because number of encirclement telling is that number of how many poles on the right hand side. So if you want to make your right hand side pole equal to 0, then the system is stable. To make the number of right hand side poles equal to 0, it means the number of encirclement also equal to 0. About which point? About this -1 plus J0 point. So I don't want any encirclement. So if assume that your -1 plus J0 point is inside somewhere here. Then how many encirclement you are seeing? There are 2 encirclement, right? If you assume that this -1 plus J0 point is here, then how many encirclements are there? 2 encirclement, right?
Yes, sir.
But if you want your -1 plus J0 point here, then how many encirclements?
0.
0. That's why for this question, your -1 plus J0 point should be left of this K by 60, right? Yes or no?
Yes, yes.
So out of tell me K by 60 or -1, which is greater? This is the negative axis, okay, not in the positive axis. If this is -1 plus J0, this is also not K by 60. This is minus K by 60, right? Because in the negative axis. So tell me out of K by 60 and -1, in this line, which one is greater? -1 point is greater or K by 60 point is greater?
K by 16 is greater.
K by 60 point is greater, right? Yes or no?
Yes, for system to be stable, K by 16 is must be greater.
You can see one. Draw the number line. This is the origin. This point is -1. This point is -2. Assume that this -2, out of -2, -1, which is greater? -2 is greater, right?
-2 and -1. -1 is greater, na sir?
-1 is greater than -2.
In magnitude wise, I am saying magnitude wise.
Minus
Yes.
2 will be greater than 1.
-2 will be greater than 1. It means out of this -1 and k by 60, magnitude wise, which one is greater?
K by 60.
Again, you are saying k by 60 is greater.
No, -1 plus this is greater, sir.
Yeah, k by 60 is less, right? K by 60 should be less than minus, I mean less than 1 if you're taking amplitude, right? So it means k value should be less than 60. Okay. So this is the one range you got, k less than 60. The other range is what? This k by 6. Okay. It should be greater than 0. Okay. It means k should be greater than 0 and k should be less than 60. So the range of k should be 60 to 0. This is the range of system stability. If your k value will be lies in from 0 to 60, then the system is stable. Then tell me at which value of k the system is marginally stable. Tell me at which value of k the system is marginally stable.
K is equal to 60.
K equal to 60. And for which value of k the system is unstable? K greater than
K
60.
greater than 60.
So that is the whole idea. Okay. If you understand the Nyquist plot, from the Nyquist plot, you can tell the values of k for system stability. For you can find out. If suppose I am just asking you in this question, then tell me if the system is marginally stable, what is the omega value? Means marginally stable means what? It will oscillate at some frequency. Now, what is the frequency of oscillation? At k by 60, what is the frequency? √11. Yes or no?
Yes, yes, yes.
So the frequency of oscillation is √11. Simple. It's as simple as that. So if at k, if I are saying that k equal to 60, the system is marginally stable, it means the system will oscillate always at a frequency of √11 radian per second. Okay. If k greater than 60, then system is unstable. If k lies from 0 to 60, then system is stable. Okay. So in that way, you have to solve some questions. Okay. This is the basic question which I have covered everything I understand. Okay. So this is the final question I'll take for this today's class. Okay. I will not do the Nyquist plot for you. You just do by yourself. I think this question I covered, right? No. At omega equal to 0, what is the magnitude and theta? Infinity. What is the angle?
-270.
Minus
Minus
270.
270. Very good. At omega equal to infinity, m and theta is how much?
Magnitude is 0.
Minus
360.
36. Very good. Ending direction equal to positive clockwise. Starting direction should be only poles are there.
Clockwise.
Okay, so let's do the polar plot. First, you have to do the polar plot of this question. You have to start with infinity. You have to start at infinity infinity and minus 270, but in clockwise direction. So let me start here like this, and you have to reach at minus 360 and 0 by making clockwise direction. Okay, so a little bit. Okay, this is the polar plot. Then the mirror image something like that. Let me change some color. This is the mirror image. Okay. Same direction follow. How many number of infinite radius half circles? 3, right?
एक आएगा ना सर, एक लेकिन राइट हैंड साइड को नहीं आएगा, लेफ्ट को आएगा.
We just see how many number of infinite radius half circles? 3.
1
How many number of poles at origin? 3.
3.
So 3 infinite radius half circles. So let me draw how this infinite radius half circle. If you start from here, you have to start here. Make one infinite radius half circle, then do another infinite radius half circle, then another radius half circle, and end here where you started. You already made one. Let me change the color. You made 2. It's a little bit difficult for me. This is 2 completed. Infinite radius half circle. Let's draw the final one. Okay. Where originally you have started, you end here. So this one is the first one. This is the second one. Okay, after doing so many questions, I don't think you have any doubt on this question. And this is the third one. This is the first one. Okay, this is the first one. This is the first infinite radius half circle, second infinite radius half circle, third infinite radius half circle, which all end at the starting point. Okay, for today's class, I am stopping here. I think you can practice a lot of questions. Okay.
What is about stability of the system, sir?
Yes, you can find out by yourself. Huh?
Yes, sir. Okay, okay.
You can take a -1 plus z0 point.
Yes, sir. Yes, sir.
Okay. You can keep the -1 plus z0 point here. You can keep here, and you can keep here, and find out the k value at this point. At this point. Okay.
Yes, sir. Yes, sir. Okay.
You can do by yourself.
Okay, sir.
I'm stopping here for today.
Thank you very much.
Thank you, sir. Thank you.